Hello students, in today's video let us see the software engineering approach in a detail, and I must say this is the one thing that your whole subject is present on, that is the phase development process. So what actually is a phase development process? See, in the last video we have seen what actually like what are the attributes for the quality. So while seeing that, we have seen how a software should be made, or what are the things or the attributes we need to keep in mind so that the software produced is of a good quality. Now, when our intention is to produce a good quality of software, it is not just enough to measure or to have the attributes to qualify your software. So there has to be uh, every at every step of the building of the software, there has to be some kind of a process that is actually followed, that is followed almost in every company that actually produces a software. So this might slightly vary from company to company because of their rules, that core values that company has, but overall all these customs they follow or the rules they have will be the same. So what is it the phase development process mean? It is nothing but your development process of a software is divided into phases. Why is it so? Because the phases are performed in the order specified by the process model being followed, and the main reason for this is that it breaks the problem of developing a software into successfully performing set of phases, that is each handling different concern of software development. See, we know how we are actually building a software or getting to create a software. How we are doing that? It's simply because we have some problem and we are trying to find a solution through software or through coding. That is nothing but a problem, how a software is actually developed. So simply there will be a problem, you are trying to solve it, that is it. But the problem will be not that easy as we 2 plus 2 is 4. Of course it won't be. So what we need to do, we need to summarize the problem, we need to divide into so many divisions and find solution of each step. Then we get the solution, or we kind of develop a unit of each answers for that problems that we have divided and subdivided. And those answers what we get in terms of the programs, we check whether it is working properly, that is a small unit or a small module is working properly or not. Then we combine it with the other modules that are directly in contact with this module, and we join them, and joining all the other modules together we get a software. So you might have at least have an idea now by now how a software is being made. Like, it's not just like one person sits and does the whole software. When it is a very bulk software, of course some of the softwares could be done individually, like there are freelancers who work on this, but that is not sufficient. Like when the software is of such a huge capacity, or the software itself is a very big one, to create that it is not possible by an individual. There will be so many people collaborating together, or so many, sometimes even the project teams collaborating together. So the each project team will be given a part of the software to be part of the software that is a problem to be, they will be given, and they have to solve that, and that is they have to create a code for their problem and they have to give it back. And there will be some team which will look after the integration of these things, and they join it and combine it to form a whole software. So this is not this does not apply to all the softwares. That is, if the software is small, only one project team will handle it, all the that integrating the testing or whatever it is. So it depends, but the whole process remains the same. That is, even it might be doing a small project team, or the whole company is having different project teams to perform one project. Okay, so that depends. But whatever the, even if it is a whole company is performing one single project, or even one project team is performing that project, the process, the two scenarios are to be followed is the same. That is, what are the things has to be done, or what are the things needed to develop a software. The first thing is the requirement analysis. What is requirement analysis? This is one of the basic thing which we need to do very carefully and very accurately, and the person who is doing this, or the team which is doing this, have to be very careful about each and everything they are about to do about this software. Why? Because once the requirement analysis is finished, the software design happens. Later on, the coding happens based on the requirements set by the user or the customer. Software design is being made by the requirements analysis, and it goes on until testing, until the software is ready. And if something goes wrong in this requirement analysis, your whole software is of a problems. Okay, so it is very very necessary in the requirement analysis stage you actually prepare this very well. Now what actually then happens in this requirement analysis? So the thing is simple. That is, the goal of requirement activity is to document the requirements in the software requirement specification document. What is this software requirement specification document? Every company has their own set of documentation process. Okay, it's similar, almost similar to every other company, each and every company, but there is a set of document. In this, whatever the document is provided with the questions, you have to answer that. Okay, and there are two major activities in this phase, that is problem understanding or analysis and a requirement specification. So it is simply that a customer comes, or the client comes, or user comes. User, we mean to say that one who is in need of that software. Okay, and you are the one who is actually creating the software and giving them. Okay, so one who is in need of this software, we can say them as a customer or a client. Customer because he pays us, and client because he is in need of our services. Okay, so he actually comes with the problem, and your thing in the requirement analysis to do is just to get his problem and make it as a statement, and for that whatever the requirements actually is needed, because he may come and say it in a simple English sentence, but to do that there might be some several mathematical formulas and problems you need to solve beforehand. Okay, so that has to be done. For that sake, you have to actually write the problem, then whatever the problems actually come in order to solve the main problem, that you have to write, and whatever extra or the additional he asks for, in the software, or the some minute things that he wants in his software, that things are added, are written up and made a document, a clean document, because that is also used in the later stages of software development. So this is a very main and important thing that has to be done at the start of the project or developing a software. So understanding requirements of a system that does not exist is difficult, and it requires creative thinking. That is, if at all there are no automated system for that problem till date, then you have to come from the scratch. Otherwise, if he has an old software, or if some other company has the old software, or somehow it is being used previously, you just need to update, then it will be very easy to get that software what was working before, and to make the changes or upgradations to that software. Okay, so these are the things. And once the problem is understood by the whoever the team is in the requirement analysis, so the requirements for this should be specified when the problem is known and should be documented, and it should have all the functional and performance requirements, the formats of inputs and outputs, and all design constraints that exist due to political, economic, environmental, and security reasons. You cannot make a software that is not under a government guidelines, right? So all these things need to be taken care of, and also in what kind of speed or accuracy he needs the answers, in what fraction of second he needs the answer, everything has to be taken down as a document. So this is a kind of a preliminary manual, user manual, that describes a major users interface frequently occurring in this software. So this phase is the requirement analysis. Once you have tackled the problem, once you have got to know what the problem is, that is, once you have diagnosed the problem, then what you do, it's simple, you actually design a software. Okay, so this is the problem we are having. For this problem we need to have this kind of software. Okay, so for this, the purpose of this design phase is to plan a solution for the problem, okay, as specified in the requirements document. So after this phase, the client does not interact with whoever the teams, the project team is working with. It's only with the requirement analysis team he speaks, and after that he is not into the picture. After this, the software design team will get the information from the requirement team and design the software according to the documentation documented by the requirement analysis team. Okay, that is starting with what is needed to design toward how to satisfy the needs, and design of the system, that some critical part affecting the quality of the software, and what are the major impact, or maybe in testing and maintenance. So all these things has to be designed by the software design team. And it actually also has three separate outputs, like architecture design, high level design, and detailed design. So architecture focuses on how actually in total a system should look like, okay, using many components, combinations, and all that. And next, the high level design means that it should be built from developing from the system that the specifications of these modules are present. That is, you cannot simply build a design just because it is there, or just because it is available. You should see whether it is feasible to the software that you are actually developing. And at the end of this, there is the detailed design, that is the internal logic, and the internal logic of the each modules are specified. So if the architecture focuses on identifying the components and subsystem and how they connect, high level is focused on identifying the modules. During the detailed design, focus is on designing the logic for the modules. Okay, and in other words, architecture focus on what major components are needed, high level is what the modules need to do, and in the detailed design, how the module should be working. Okay, so this is how a software design is a team should be working. And in this process, these three design phases are also present. So once the design is made, that is, you have, it's like you have the blueprint of your home, and next what we do, we laid the foundation, that is nothing but coding. We just code. So what is coding again? You might know, writing some of the code, programming, right? Programming the things that have been designed in the software design are put into programs or codes, so that we can actually get the result of whatever the problem, or the solution for whatever the problem we are having. So the coding phase affects both testing and maintenance profoundly. So there is one more test, actually one more phase after testing, that is maintenance. That is we see it after the software is actually prepared or built. So the aim of coding is, as I told you, to convert the design into a program or a software. That is the main intention. And if the code is written well, the maintenance or the testing becomes easier. There will be less errors. If you test for 1 or 2 times, you get the results also. It is not that easy usually, but if you do that, if you're a great coder and you get no errors, the things become easier and happens very, and the software is developed very easily. You should, while coding, there are some things you should keep in mind. That is, one thing is simplicity. Simply because you are given with a chance to code, you cannot make it a complex one. So whatever the simplest way is there to code, you need to code it. Okay. And next is the clarity. There should not be the ambiguous results or conditions in your programming, so that the program or the working of the program will be at fault. So we should avoid those things, and we should make as simple as possible, and as well as the clarity should be maintained. So once the coding is done or the software is developed, next important phase is the testing. And testing again has so many mm, divisions in it, or you can say the hierarchy in it. That is unit testing, integration testing, system testing, and acceptance testing. So what are these? Simply put, it is nothing but, as I told you a little earlier, every system or the program has to be divided into smaller problems, right? Then smaller problems are programmed to get the solution, and this individual word solution, we called it as a module or a unit. So these smaller units has to be tested first individually. So is if the whole set, that whole unit is working properly, only then we are actually going to the next step, that is integrating. Integrating is nothing but when two or more units are working properly, we combine them or we join them together and ask and see if it is working. So we are making sure that there are no problem in integrating the two units. Okay, after this integration, we are trying the system testing, that is putting all these kind of integrated tests together and forming a system. That is the whole software that we have developed. We are putting it together and seeing if it is working. Then finally is the acceptance testing, that is some of the real life data is actually taken and testing whether the software is working properly or not. Okay, so this is the acceptance testing. So after this testing, what we need, this is one of the actually the time consuming one, and actually it's a very required process also. You cannot simply skip the testing in any case at any cost. Okay, so this test again comes with a test plan that identifies the test related activities that must be performed and specifies the schedule. So once the resources are allocated and the specific guidelines for testings are followed, then the test plan is continued and the actual test is done. And we use some of the test case specification document is produced, which has the test cases in it. So according to one test case, what is the result? What is it? According to another test case, what is the result? What is the best case scenario? What is the worst case scenario? So what are the border conditions? All this we put into the test and see if we are getting the result or not. Okay, only then a software is given to the user for using. And in the testing phase, we get this test report. If it is all the test is right and it is good to go, then we actually launch the software, or we just give it to the user. Otherwise there will be an error report. That error report is checked and again execute, again the program is corrected, or the coding is redone and then again tested. So this happens until all the errors in the program are gone and the software is finally being built. So next in this is the managing the process. So we have seen the phase development process. So next is the managing the process. So how we are actually managing the process? See, it is not just enough that we divide the software into phases and do whatever it takes for the getting the solution for the problem. But we also have to plan the process. That is, it is a baseline that is heavily used for monitoring and controlling the development process. See, anything that is not given attention, like how the process is going on, the process is you can say it is not growing as needed. So there has to be a plan, like up to when what process is to be done, or up to when what should be done, and after that what should be done. And if we are if the last date or the deadline crosses, then what need to be done, how should we actually uh, process the software development so that it gets finished in time. So that monitoring is very important, and not just the phase development. See, if we take it as a phase development, and if we take for 20 years for building a software, it's of no use, because in 20 years the technology itself gets obsolete, right? That is the hardware part I'm saying. So if the hardware isn't working, what is the use of building a software like that, right? So it is important that you manage the time for this. That is nothing but managing the process. So it requires mainly the plan, like in what time what has to be done. Like for example, for requirement analysis, how much time is needed. For software design, how much is needed. For coding, how much is needed. And for testing, how much time is needed. Then after this is done, what we are doing, we are trying to get the software metrics we have seen in the last video. That is nothing but actually we are trying to scale in the sense trying to measure something out of it. Okay, as I told you, so to measure software, it's not that easy, but still we are trying to do two things in this, that is product metrics and process metrics. Product metrics, you can say, that is quantify the characteristics of the product being developed, that is actually the software itself. And process metrics are used to quantify characteristics of the process being used to develop the software. So process metrics aim at measuring such considerations such as productivity, cost, resources, effectiveness of quality, effect of development techniques, tools, everything. Okay, and whereas the product is the whole software, how it is working. So for effective monitoring, the management needs to get the information about the project, like how far the project has been going, how much development has taken place, how far behind the schedule it is, as I told you before, and the quality of the development so far. See, for every process in the software development, there is, like, a quality need to be followed. There are some standards that we need to follow, like especially the IEEE, or some of the international standards are there. They give the a standard for developing a software. Only if that standards are met, only then you can say a software is of good quality. So every in every step of the development of software, this standard has to be followed, and the company or the institution has to check whether these standards are being followed by the team or not, or whether they are skipping this rules and regulations that has been put to them. So all these things has to be checked, and you need to do this software metric, like you have to quantify the software that is being produced. So this is about managing the software, and this completes the first chapter of your software engineering. Thank you.